Hello everyone. Now in this video we will see how to draw the orthographic projections from the isometric view of a solid. As on the screen you can see that this is the solid which is of a block with a circular hole exactly at the center. So now based on this one we will see how to draw the projections. So to start any drawing, first the observer direction is very much important. So in the question they will be specified with a arrow mark that represents the front view direction, means the observer is standing in this side and is having look towards this side. So this is the observer direction. Okay, you can see that this solid I kept in the first quadrant because we are following the first angle projection. So this is the first quadrant. In the first quadrant you can see that vertical plane, horizontal plane and profile plane. So in the vertical plane we can draw the front view because in the question the arrow mark is represented this side, this represents front view. So the front view falls on the vertical plane, and exactly 90 degrees to this front view direction you can see the top view. Top view falls on the horizontal plane, and exactly 90 degrees to both these directions will be the side view, and this side view will fall on the profile plane. So to draw the projections, vertical plane, horizontal plane and profile plane. Okay, first let us draw the front view. Okay, now observe is viewing from this side towards this one. When he looks this side you can see that this one will be highlighted. He will have a clear look of this rectangle and clear look of this rectangle, not any other. So when he looks at this side you can see that from here to here 45 and from here to here height is 30. So 45, 30, 45, 30. The same you can see that from here to here 45, 30, 45, 30. Okay, after this one you will have a clear look of this rectangle also. So this one is 15, 30, 15, 30, and the same projectors will fall here. You can see that 15, 30, 15, 30. So with this we constructed two rectangles, rectangle 1 and rectangle 2, because when he views from this side this is the only clearly visible. Okay, so we finish this one, and here we are having a circular hole backside to this face, backside to this face. When the observer views from this side this is invisible, this hole is invisible. So that's why we represented with the dashed line, represents hidden lines, hidden edges. So you can have a clear look. The location is that 25 from this side, so axis will be here 25 and the dia will be 30. Now let us draw the same in the AutoCAD. So first I am going to draw the 45, 30, 45, 30, this one up to this rectangle. Okay, take the line, (45, 30, 45, 30). Okay, I made 45, 30, 45, 30 DA. Yeah, and now I am going to draw this rectangle, this portion 15, 30, 15, 30. Okay, from here 15, 30, 15. Perfect. So now we completed this rectangular portion, and now this circular hole is invisible as I said, so we need to represent with the dashed line. What is the location of the center line? From this edge 25 mm. So now I am going to mark the 25 mm line. Take the line 25, just delete this line. Okay. Okay, now the dia of the hole is 30 mm. So from the center line 15 this side and 15 that side. So what I am going to do is that take the offset command, specify offset distance 15, 15, 15. Okay. Perfect. So we completed the front view. Okay. We load the line types to represent the center line and the dashed line. Center 2 for axis lines, dashed 2 for hidden lines. So these two are hidden lines, that's why I am going with the dashed 2. I will change the size line type scale 0.75. Okay, perfect. With this we finish the front view. Now the top view falls on the horizontal plane. When the observer views from this side and this portion, he can have a very clear look. So he can see that this is the size of 50 mm and this one will be the 60, 45 plus 15. So 50, 60, and from here to here 35, 35, and from here to here 15, 15, 45. So this is what he can see from the top view very clearly, as well as this circular hole. When you see from the top, you will have a clear look of the circle. See, the same we drawn in the top view projection. 50, 60, 35, 15, 15, 45. Now the same I am going to draw in the top view. AutoCAD. Okay, I am taking the projectors. Okay, so in the top view you can see that this is the 60 and this one 35, this one 15, 15, 45, 50. If you observe carefully, you can see this projector will exactly match to this one, and this part represents this one. This rectangular part represents this one, this part, top view. From here to here You can see that perfectly. And now you can draw a circle, and this is the location is from this side 25 mm, from the top this edge 25 mm. So that's why I am taking the line from here 25. This is the center point. Now just I am deleting it. Take the circle, and this is the point. Radius is 15. If you draw the projectors from here, exactly it will match to this one. See, perfect. So this one represents the hole, circular hole in the block. So front view and top view, we finished it. Okay. Now these two, I have to mark it with the center line. Okay. So with this we completed the top view. We should not give any line weight to the any projector, only line weight to the visible and invisible lines only. This circle is also visible. Perfect. Let us give the dimensions. DAL. Yes. Now DAR. DRA, dimension, radius. Radius is 15. So now we complete the front view and top view. Side view we need to draw. Yes. See, when you view from this side, the observer is viewing from this side, front view and top view and side view. So the side view, you are looking at the right side, towards our right hand side we are looking. So that's why it is the right side view. When we are looking from the right side, it is a right side view, but this view will be placed on the left hand side. Right side view will always be on the left hand side. Left side view will always be on the right hand side. So that's why now the person is looking from the right hand side, so the view will be on the left hand. So to draw that one, okay, so first draw a line. Okay, and from now (135) 90 plus 45, 135. You can see here (45 degrees). Exactly, you need to keep 45 degrees. Okay. Later again I will mention the dimension. Just I am deleting it. Later I will do it. Okay. Now when a person is viewing from this side, this one will be highlighted. This one, this one, this one, you can have a clear look. So height 30, 35, 30, 35. You can see the projectors of this one from here to here, 35, 30, 35, 30. And one more rectangle is 15, 30, 15, 30. You can see from here 15, 30, 15, 30. So two rectangles you can see here. And one more thing is that, as we saw in the front view also, this circular hole is invisible to the observer from this direction. So that's why we represented with the dashed lines. When you view from this side, this is back side to this face, which is invisible. So that's why represented with the dashed lines. Dia 30. The location is from this side 25 mm. So the axis will be 25 mm here. We can draw. So 35, 30. So how to draw this one? You can see that as already I drawn the 45 degrees line and now draw the horizontal projectors from every point of the drawing. Okay, we finish this one, this one, this one, and from here to okay. Now I drawn the horizontal projectors of the top view. Now I am drawing the horizontal projectors of the front view. Here only two, nothing is there, this one and this one. Okay, now what I am going to do is that just I am drawing from the intersection point this 45 degrees line and this horizontal projectors. From the intersection points I am drawing a vertical projectors. It's not a vertical projector, vertical lines. From every intersection point I am drawing this one. Okay, so this is the reference line. Let me give text. Command line, text 60 x y, vertical plane, horizontal plane. Okay. So I am going to trim all this portion. And this is unnecessary portion, I will delete it. Yes. So 45 degrees line and then draw the horizontal projectors. From here you draw the vertical projector, vertical lines. If you observe, see, this is the one which matches this one. So this is the rectangle from here to here, the complete, see, from this line. Okay, let me mark from here to here. This projector is this one, and from here this line. Okay, so from here you can see that here one more line. from here to here I drawn a, yes, so this one okay, this one, this one. Instead of brown color I am drawing the yellow color here. So let me give the dimension, we will come to know what is this. See, 35 this block, so that's why from here to here I took these projectors and then we made it here. As we saw here, 35 30 35 30, this rectangle, see, from this portion only I made it. Okay, now the next one is that from here to here, so take the line from here to here, these are the projectors, so that's why I am dropping it as. Okay, this one, this one, so we finished the second rectangle also, 15 30 15 30, because I took it from this side, this one to this side. You can give the dimension 15 mm, height is 13 mm. Okay, now we finished this one, the rectangular block, and coming to the circular hole in the side view, we know that this represents as a hidden line. If you observe from this projector to this one, so this represents the hidden line of circular portion. So drawing, okay, and from here this is the circular one, from here to so represents hidden line, dash it to. You can see that perfectly we got it, this one, the same view we drawn here. You can see the exact location of this projector. So this is the axis of the hole. Let us see what is the placement. See, 24, perfectly we got it. Here also you can see that from here to here 25, total distance is 50 off, so 25 we got it perfectly. So after drawing, front view, top view, and this one, the view is on our left hand side, represents right hand side view. So right side view. So this is how we need to draw the orthographic projections from the isometric view of a solid. So in this video I discussed the conventional method. In the next tutorial I am going to show you additional advantage method using the AutoCAD. You can look it out the next method how we can draw in the AutoCAD also the same projections.